Good morning, good afternoon, and good evening. I'd like to thank PTV for this opportunity to present this webinar, which is PTV Vissim COM programming in depth. It involved the introduction of Vissim COM's patterns, extensions, and performance tips. A little bit information about myself. I'm a software developer, traffic engineer, and researcher. I have more than 20 years experience in this area, and my specific domain is traffic simulation, modeling, optimization, adaptive traffic signal control, artificial intelligence, and ITS system integration. I have a personal blog, and my GitHub repos is here, and my LinkedIn profile is here. About KLD, my employer KLD is a New York-based consulting firm. KLD does professional engineering services on the areas including traffic simulation, control, modeling, and optimization. KLD also does ITS architecture and standards, and data analytics and artificial intelligence applications for intelligent transportation system. KLD also specializes in emergency evacuation planning and relevant research and development. So for this webinar to be effective, I made some assumptions to get the depth, to get the real depths. So basically, I expect you have prior experience using Vissim Traffic Simulator, and you have some exposure to Vissim COM programming previously, like using Python, MATLAB, Visual Basic Script, doing the scripting. And also, it is best that you have some experience using COM-compliant programming languages such as C++, C#, Delphi, Fortran, so on and so forth. But if you do not meet these assumptions, no worry, that's not a problem, because this webinar is being recorded and you can always revisit. And also, you can refresh yourself on a wonderful previous webinar, scripting in PTV Vissim using COM interface, which was published on YouTube. That provide a very solid foundation on various basics aspects of Vissim COM programming. And also for all of the demos used in this webinar, they are all open source, and you can access those demos from this link. And so here you can get all these demos here. Now, an agenda for the webinar will cover several subjects. The first subject would be to present the Vissim COM patterns. It will discuss the compositional hierarchy of the COM interface design. And one important aspect of Vissim COM that people always sometimes might just omit is the reference counting issue. And then Vissim COM allows a beautiful language integrated query, the query expression that probably very few people are aware of, that you can use to write elegant and neat code. And also, I'm going to introduce a so-called COM type provider, which is an open source project that I developed that can streamline the Vissim COM programming. And the second subject would be the extending Vissim COM type system elegantly. Vissim COM is a powerful type system that provides a lot of the types to facilitate customized simulation customization. Sometimes you can even extend the Vissim COM's existing type system without even accessing the source code, the Vissim COM source code. And the third subject covers the performance aspects. We'll discuss some of the typical causes and remedy for the performance hit of Vissim COM applications. And we'll show some interesting demos that you will see that we can accomplish as fast as up to 600 real-time factor by doing some of the tricks. And finally, we'll do the summary and question and answer. So let's start with the Vissim COM patterns. The first question would be, what is COM? COM as a matter of fact, is a pretty old technology. It's the so-called component object model. It starts as like 30 years ago. That's a very long time ago. Basically, it is a binary level interface technology. It is actually the foundation of Microsoft Windows operating system, like the Microsoft Word, like Microsoft .NET. All of this technology, Microsoft technologies, are pretty much based on the COM technology. It provides a multiple language support, such as C++, C#, Fortran, Delphi. The primary aspect of COM is that it's interface-based. Basically, you define the communication contract between the client, which might be written in language A, could be in C++, and a server, which could be written in another language, such as Fortran or Delphi. It greatly facilitates the interoperability, such as the in-process communication or out-of-process communication between different processes. The types are defined in the so-called type library using the interface definition language. Vissim COM is actually a COM-based programming interface of Vissim Traffic Simulator. In my opinion, it is one of the best gems, one of the best thing that Vissim provides for its users. The type library is embedded in Vissim executable and can be imported to the type system of a specific programming language. This one shows a file, so shows the type library that has already been extracted from Vissim. This is the raw format of the type library. And when we import the type library for a specific language, for example, Delphi, we import component from here, and we just so this is the imported type library for Delphi. You see, this is already very native to the Delphi languages that provide all these types in the Pascal language. So in this example, we already have the Vissim type library imported. This is an interesting example so you can have a preliminary view what we can do. So let's launch this. So we can start Vissim. So if you look at the code, you see the Vissim, we created the interface, the reference to the Vissim interface. Okay, so Vissim just launched, and we can, okay. This just to show the power of the COM interface. We can hide Vissim, so the Vissim just completely disappeared from the desktop, from nowhere. We can find it anymore. Or we can show Vissim, and we can embed Vissim. So we can embed Vissim into another container. This way, you can do a lot of creativities, and your imagination can help you to do a lot of cool applications. Now, let's close this. To import the type library for C#, all you do is just similar like Delphi. From the references, you add reference, and you go to where Vissim executable is located. So this will generate a generate Vissim lib assembly for the .NET application. So similarly, very similar like Delphi, except it's a .NET in the .NET environment. Now, after we imported the type library, let's look at the hierarchy, the design hierarchy of the Vissim COM interface. Basically, if we look at this, the picture on the right side of the slide, we see that the Vissim COM interface is really a compositional pattern. It's not like object-oriented inheritance relationship. All different interface objects are of a compositional relationship. This is actually provides the great power and flexibility in a balanced way. So it's very intuitive and easy to follow. You just you don't even have to extensively to look through the code. Just intuitively you can figure it out when you are doing programming. Some noteworthy points for this compositional hierarchy is it suits the engineers as well as developers and system integrators. There is no complicated connection point COM event callbacks. For a typical COM application, the COM event callback are generally accomplished by a very sophisticated connection point mechanism. I guess it's the design decision that for a balance, for flexibility and ease of use, Vissim didn't use connection point to callback. Another design aspect, interesting design patterns is that Vissim consistently use the dynamic property getter and setter using the attribute value. This is a unified way of accessing, setting, and getting different attributes of a Vissim COM interface object. It's very extendable. So in the future, if Vissim add more properties, more attributes, the entire interface remains very stable because it's a dynamic property access. And there's another a containers design pattern that allows different type of loop options. Later, we will have an interesting demo showing the loop performance to illustrating the implication of the performance implication that using different type of loops. So looking back again at compositional hierarchy, we can recognize that iVissim really represents the Vissim app, represents the entire application domain. Representation of elements for composing a simulation model, like links, sensors, and inputs. And also this iSimulation interface represents a behavior representation of the simulation runtime. These are the two primary sub objects of the entire hierarchy. And also the container pattern. I'd like you to pay attention to this. The container pattern following this, there is I collection base, and then I something collection, I something container base, I something container. For example, we can have I link collection, I link container base, I link container. So the X can be link node behavior. This pattern, once you understand what's going on, what's under the hood, you're going to realize that it provides the powerful link style looping, the language integrated query style looping. So we have a demo later showing this. And for Vissim COM patterns, one thing that we have to pay attention is that every interface object are reference counted. So we should avoid coding like this, like below. You see here, we instantiate a Vissim interface object, and then we load the network, and then we do a very tedious looping from 1 to how much, to this huge number of iterations, and for each iteration, we access the simulation, and then we call run single step. the chances that you will probably encounter this error message, the maximum number of simultaneous active comp references was exceeded. The reason is that every time you call the Vissim through the simulation property internally, it will increment the reference count for that iSimulation interface until it reaches the limit, and you get this error message. So we should avoid coding like this. And recognize that we should write code similar like below. We should keep the simulation as the local variable. Just save it once. So every time we just access to run single step through that saved local variable. This way, we maintain a very low number of reference count. Or, which is not recommended, you could always bump up iVissim attribute value, the maximum number of comp references. You can use this attribute, you can bump up this attribute if you are, say, using MATLAB or Python for some scientific computation-based applications. Chances that you might need to use this to change to bump up the maximum number of comp references using this mechanism. But overall, do not put the references in a very tedious loop, so the reference count do not keep incrementing indefinitely. Another interesting pattern of Vissim COM programming is the so-called link, which is the so-called language integrated query, which is a very good thing from the .NET world. And essentially, when we are searching some data-centric, we're querying some data, for example, from a list of Vissim links. We want to find out a subset of links satisfying certain conditions. We can always accomplish that from a loop, a procedure type of loop, imperative style. But link provide a way to do a functional style query expression, which is more readable, which also makes your logic, your business logic, really expressing what result you want without distracting the implementing details. So the reader, anyone who read your code, doesn't get distracted by the extensive loops. It's also more expressive and powerful. Replacement of Vissim default iConnection base filtered by. That method is, you can also do query, but it's kind of limited. And what's under the hood is that why the iConnection base interface allows this link, because in the Vissim's type library, it has a very special method called new enum and a very special magic flag. This flag, when you are importing the Vissim type library, the type importer will automatically generate IEnumerable interface implementation of the imported object. That makes your coding possible to use the link. And we are going to have an example to show that. So link is more expressive and than the Vissim default filtered by. And for ours, but because when we are using Vissim COM, we are most of the time are doing the domain specific development. And the link, the functional style coding is very good for domain specific development, and we should use link as best as we could, as best we can. That allows us to do the sophisticated and expressive SQL-like query. It even allows us to do very complicated, elegantly recursive search of the link node graph. Can do a lot of cool things. So this picture shows that how we can select some certain links using the link query expression syntax. It's very much like the standard SQL expression. This completely hides the details of the tedious loop, while makes it very easy to read and very easy to understand the intended business logic. So that's the Vissim COM patterns link. And then we, as we just illustrated before, just earlier, we need to import the type library, like the Delphi, like the .NET. We have to import type library to create a a separate assembly that containing the Vissim comps types. I have an ongoing open source project called Vissim COM type provider, which provide a streamlined, better way. Well, I think it's better of integrating Vissim COM type system without the need to import a type library. So it's open source, it's pretty cool, and here is the The COM type provider is a compiler plugin that makes Vissim type system automatically part of the compiler type system. You don't have to, without importing any type library or type libraries or adding references explicitly. The good thing is that if you installing new Vissim, uninstalling old Vissim, everything it will be automatically collected by the COM type provider, rather than you have to manually import again and again. Now we have some high-level understanding of the Vissim COM hierarchical type system. Typically, occasionally, we have the motivation saying that how can we add a user-defined methods to existing Vissim interface? Say we have the iVissim interface. How can we add two methods so we can hide Vissim main window, restore Vissim main window, just naturally. So it's naturally just like just looks like naturally. It's just part of the original iVissim interface. You don't have to resort to sophisticated or a messy object-oriented wrapper class. And the answer is we can use the elegant type extension, the intrinsic type extension. If you're using F#, which is the functional language provided by the .NET, or the extension methods of C#. The extension methods feature of C# is a feature provided by C# 3.0 and newer versions. And let's see a demo, see how we can extend the Vissim type system in an elegant way. Here we are. So here is a list of all the examples. Now let's look at the Vissim extension. Now, you see here we get a sample and we use C#'s so-called feature extension methods, which is a compiler magic that will sort of insert or merge the user developed additional methods into the iVissim interface. So we define the name of the method and we designate the target of the interface. So the effect of doing this is like here. After with this extension methods, now we just normally instantiate a Vissim interface, and then these two methods will automatically become iVissim interfaces. Say hide. You see, hide main window. This way, we don't have to resort to the very messy or the cluttering code using the object-oriented inheritance, this type of thing, which is not very good for domain-specific modeling. And you see here, we get a hide window, we got restore window. This way, we can extend the existing Vissim interface type system using the C#, so-called C# extension method. It's pretty cool and very elegant. For if you're using F#, F# is even more elegant to extend the Vissim type system. Here, we just use F#'s intrinsic, the so-called intrinsic type extension to use F# intrinsic type extension to extend Vissim. So we add these two additional methods to the iVissim interface. And here we can just directly treat these two extension method as if it's just part of the naturally the Vissim original iVissim interface. It's very elegant. and it allows you can this way even though we don't have access to Vissim COM's source code, we can always extend the Vissim type system like this to have a very elegant solution. Now, when we are running Vissim COM applications, sometimes we get the performance hit. You observe that the application is running very slow, and sometimes it's unbearably slow. A typical reason for the COM performance hit is the typical cause is that you access the dynamic property retrieval for each and every individual add value in a long loop. Typically, say if you have a signal optimization algorithm and you're trying to access certain property of certain object, and for a very long, tedious step-by-step loop, you're accessing that property and you're setting it to a different value for each and every individual attribute in the tedious loop. This will have very big runtime cost because internally add value will do an internal dictionary type of search based on the provided string-based property name, which is not very performant. It has runtime cost. And also, if you run a Vissim simulation with the animation on and lots of data view window open, that also has runtime causes. Because if we have the animation on and a lot of data view windows open, Vissim will redraw and the updating data. That has a huge runtime performance cost as well. So the remedy would be to update, to get and set for each property using in a batch mode, because Vissim already considerably provide a very good batch mode data processing, which just use multi-attribute values or multiple attributes methods. This could get you up to 5 times faster. In the loop performance demo, we'll show that benefit of using this batch mode loop. And for running simulation, sometimes when you are doing the Vissim COM application, we really do not need to see the animation because everything would already be examined, would already be verified. There's no need to just let animation running. That way we can turn Vissim quick mode on, so Vissim do not update the network. Do not redraw the network view. Suspend update GUI, and we can also hidden the main window. Remember the just two extension methods we just have implemented, which to hide Vissim. Remember this two extension method we just implemented: hide Vissim window, hide restore main window. So we can use this together with quick mode on, suspend update GUI, and hiding the main window. This way, we don't see the Vissim user interface showing up on the desktop. It's just running silently behind somewhere. You won't see it. And this can speed up to 60 times faster. That means you can accomplish a real-time factor as fast as 600 faster than real-time. That's pretty impressive. And we can show that in the demo hide Vissim, which we'll show a little bit later. The reason why we are so obsessed with performance is we can use Vissim COM to do a lot of cool things, like that very computational extensive, like the calibration, like some intelligence applications that really require faster than real-time simulation, much faster. So we can run artificial intelligence application to generating significant amount of big data in real time or offline, performance is important in for those applications. Okay, now because the time is very limited, we only have 40 minutes or so. So here's the list of examples to showing the application of Vissim. Now, we just demoed the Vissim extension, Vissim link. This is the Vissim link example, and here, as we can see, we just instantiate the Vissim interface, and then we do the selected links, and we use this wonderful link query expression. The good thing is that we can really do a lot of things. We can do a lambda expression to have very sophisticated predicate certain conditions. For example, some conditions saying I want to search. So this is the subject link, and I want, for example, I want to search a subset of the links that within 50 miles of the subject link. But of course, you have to define this this function, so on and so forth. This makes the business logic very clear. You can implement the same logic equivalently using a tedious loop, but it's not elegant, it's not readable, and everybody will suffer when reading the code. Using the link, you get a very clean and elegant way to express what you expect results to be, rather than to distracting by the unnecessary implementation details. And for the loop performance, okay, the loop performance, basically Vissim support 4 types of loops. The first type of loop, you can just do a ordinary array type of loop. So here you got using the get all, which essentially returns an array, and then we loop through the array for each and every indexed element. Look at this. We use the attribute value to retrieve the property, number, vehicle type, speed, so on and so forth, with each and every loop. Critical application. Another type of loop is the IEnumerable type of loop, because Vissim, when imported the type library in the .NET, it will automatically implement IEnumerable interface for the Vissim's collections. So here we can use the for in. This essentially is IEnumerable. This is also expensive because we are still access the each and every property for each individual loop. And the third would be iterator. Iterator is it's similar performance impacts as the IEnumerator. You see, for each iteration we access the attribute value. This is also very costly. And then we get the multi-attribute values. This is like a batch mode update. We set the value in a very batch mode. This is much faster because the data is set or get in a batch. Even faster is the multiple attribute loop. And we can see let's see the results. Let's see the we'll see the different performance impacts of these different looping options. Now you see, if we are using the multiple attributes loop as the baseline, so we see it's number one has the speed factor 1. We'll see that the multi-attribute value would be 1.4 times slower than multiple attributes loop. The iterator loop is slower, almost 5 times slower. And the enumerable is even slower, it's 8 times, 9 times slower. And the get all loop, it's still not that bad, not that good, 5 times slower. So this shows that when we are doing a loop extensive, the property attribute retrieval, getting a setting, we had best use the either multiple attribute value loop or multiple attributes loop. Another example is to hide Vissim. This one is really benchmarking. Okay, we're benchmarking, say, different options, how to run Vissim COM, how we can run Vissim COM in a fastest way as possible. So we have several scenarios. First, run Vissim without user interface. For this scenario, we just use the previously developed extension methods to hide the Vissim main window. So we don't see Vissim graphical user interface at all. And just let Vissim run. This is the first scenario. The second scenario is to run Vissim in a so-called turbo mode. The turbo mode is just the name I made up. Essentially, for the turbo mode, first we turn on the quick mode. So we don't have the Vissim rejoin the network, and we suspend update UI, and we hide main window. This way this I call turbo mode, and then running Vissim with GUI, with the graphical user interface. And let's see how much time it takes. This is the last demo before the question and answer. So let's just say boot performance, hide Vissim. First it will run Vissim increase the speed a little bit. You see now the Vissim user interface completely disappeared. It just magic happened, just disappeared somewhere. You cannot see it. And Vissim is silently running. You see that Vissim? Where's Vissim? You see Vissim is running at its full throttle, except we don't see the graphical user interface. We are running the simulation with a simulation period of 3,600 seconds, which is 1 hour. It will run a minute. So let's just wait for a minute. Okay, let's let it running, and we'll revisit. So, how far Vissim COM can go? Vissim, as we can tell, that Vissim COM is a very well designed, flexible, and powerful programming interface. It can satisfy the everyday simulation modeling tasks, such as the workflow automation. Probably that is the most common use case of Vissim COM. Server farm, like the AI training. That's a very important aspect, the use case of the simulation, because we can, for example, the Google's AlphaGo, they can use they can self-train itself. But for traffic-related AI, the simulation is a good tool, is a good scenario generator to train the AI engine. And also can use Vissim to do a high-performance offline runtime model calibration and real-time simulation. It can be wrapped up as a RESTful APIs for microservices or Internet of Things services for connected vehicles. A lot of cool things. And also it can be used in integrated corridor management system. It makes development of such systems so easy. And it can also be used because Vissim itself, if you look at it as a sort of a database management system, because it's not only a simulator, it's also a management system. You can use Vissim in a traffic and transportation asset management type of application. And so much more. And creativity and imagination is the limits, all due to powerful and feature-rich design. It's a very good. Should be finished in a minute. Finish. While it's running, we can see. We have several other. We have a couple of other examples. All these are open sourced without any limitations. You can freely review this code to get better understanding and to review the Vissim link, Vissim extension, hide Vissim, and the basic command. The basic command shows. Basic command is much faster. We can run it. Oops, sorry, not this one. This is now we are running the basic command sample example. You can review the example to get a better idea how to run Vissim COM in the beautiful F# language. Okay. Alrighty, so we just finished the Vissim speed benchmarking. So for the first scenario, running Vissim with hidden main window get the real-time factor 12, which means we take almost 300 seconds to run a simulation period of 3600. Wow, let's look at this. If we are running the Vissim in turbo mode, it only takes 10 seconds to run the 3600 second simulation, which is the real-time factor 331. This is not as fast as I saw yesterday, which was 600, but still 331 faster than real time. That's still impressive. And now it's running with the normal main window, which I can tell you directly, this real time factor is just 10. So to summarize, if we are running Vissim with the hidden main window, it's a little bit faster than running Vissim normally with a normal graphical user interface. But if we turn on this turbo mode, well, which means we hide the main window, we turn on the quick mode, and we suspend the update and agree, we can have a real-time factor more than 331. Unbelievable, and even more unbelievable if you see the number I saw yesterday, which is 600. Something's wrong with my computer today. Anyway. Benchmarking, look at the basic commands. This just shows a very organized way to get yourself started with the Vissim COM programming.